In this video, we're going to look at another example of improper integral and how to determine if it converges or diverges, and if it converges, what it converges to. So here is the problem. Determine if the improper integral from minus infinity to infinity of 1 divided by 1 plus x squared converges or diverges. Clearly, this integral is improper because it's an integral from negative infinity to infinity. It's an unbounded interval. So if we look at the function that's being integrated over the entire real line, we realize this function is symmetric to graph with respect to the y-axis or about the y-axis because it is an even function. And let's take a look at its graph over the entire real line. You can use Desmos to do it. The graph is not necessary to solve this problem. It only illustrates what the integral is going to compute. This is what the graph looks like. You can see the symmetry. The highest point is 0, 1. And you can see that the area enclosed by the graph of this function and the x-axis is always above the x-axis. So what we can see is that the integral represents this area from minus infinity to infinity, and because the region is above the x-axis, we expect our answer to be one of two things. It's either going to be a positive number, so the answer will be a positive number if the area is finite, or the answer will be plus infinity, positive infinity, because again the region is above the x-axis. We'll need one more thing, one more fact that will solve this problem for us. We need to recall the graph of arctangent of x or inverse tangent of x. These are the two notations that are used to describe this function. The function has two horizontal asymptotes. One of them is y equals pi over 2, and the other one is y equals negative pi over 2. So here's the graph of arctan of x from minus infinity to infinity. From here, we can conclude that the limit as x approaches infinity of arctan of x is equal to pi over 2, and the limit as x approaches infinity, negative infinity, of arctan of x is negative pi over 2. That's what we need, and now we can go ahead and evaluate the improper integral. So the integral negative infinity to infinity 1 over 1 plus x squared dx. First we'll split it up into integral from negative infinity to 0, 1 divided by 1 plus x squared dx, plus the integral from 0 to infinity, 1 divided by 1 plus x squared dx. We could have chosen some other number. It does not necessarily, 0 is not the only number. And so the two integrals are improper, so we can write them in limit form. First one is limit s approaches negative infinity for integral from s to 0, 1 over 1 plus x squared dx. And the second one is the limit as t approaches positive infinity of integral from 0 to t, 1 divided by 1 plus x squared dx. So, of course, both integrals are arctan of x. The first limit is limit s approaches negative infinity, arctan of x, evaluated from x equals s to 0. And the second limit as t approaches positive infinity, arctan of x, evaluated from 0 to t. And let's plug those in. We have limit s approaches negative infinity, arctan of 0 minus arctan of s, and then plus limit t approaches positive infinity, arctan of t minus arctan of 0. We recall arctan of 0 is 0, so this leaves us with the first part would be minus the limit s approaches negative infinity, arctan of s, plus the limit t approaches positive infinity of arctan of t. And so the first limit is minus, we have a negative there, and the first limit is negative pi over 2, so minus a minus pi over 2 plus pi over 2 equals to pi over 2 plus pi over 2, which is equal to pi. So the integral converges to pi. And here's method number 2, and you can use either one of them, whichever you feel is easier. For the second method, you have to be sure about symmetry. Clearly, the graph, as we saw earlier, is symmetric with respect to the y-axis, so we can use the symmetry. And using symmetry, our improper integral from minus infinity to infinity, 1 over 1 plus x squared dx, will equal to 2 times the integral from 0 to infinity, 1 over 1 plus x squared dx. And we already did the second integral more or less, so let's just do it again. It's the limit as t approaches positive infinity of the integral from 0 to t, 1 divided by 1 plus x squared dx, which is 2 times the limit t approaches infinity, arctan of x, evaluated from 0 to t, which is equal to 2 times the limit as t approaches infinity of arctan of t minus arctan of 0. Again, arctan of 0 is 0, so this is equal to 2 times the limit t approaches positive infinity of arctan of t which is 2 times pi over 2, or pi. And once again, we draw the conclusion that the improper integral negative infinity to infinity 1 over 1 plus x squared converges to pi.